Dear students, detailed civil engineering courses like manual building design, Stat Pro, ETAP, SAP, Revit, AutoCAD, Primavera, P6 are available at Civil Engineering Shravan online application app. So download the application from the Google Play Store now. Each course contains 50 plus high quality video contents and free PDFs and exercises, and online certification will be provided after completing the course. Course will be available at 67 to 70% discount now and valid up to 6 months. Download civil engineering application now from Google Play Store, or direct link is available at the description of this video. Try to utilize this offer. Please click on subscribe button and click on bell icon for more interesting updates on civil engineering concepts.
In this class, I will explain you complete designing of G+3 building structural model by using SAP2000 software according to the real-time project considerations. So initially, I will explain the specification which I am considering for the particular project. Now you can see this is the project which is consisting of G+3 building model. So I was explained same concepts related to real-time project design by using ETAP software also. The same typical floor plan I was considered for the ETAP software also. Now we can see these are the column positions we have to consider for this building, and these are the dimensions for the rooms, each and individual rooms which we are considered for this project. Okay, so initially I will assume the center to center distance between the column. So here it is consisting of the sum of the other rooms dimensions, etc. So you can consider your dimensions by converting these values from feet to meter. So for example, just I am assuming the values here. So here you can see it is consisting of the horizontal grid direction here like this. Again it is consisting of horizontal grid here. Again one more grid here like this. In the vertical direction it is consisting of one grid, and this is the second grid, and this is the third grid, and this is the fourth grid. In the same process it is consisting of one grid here. Now the center to center distance between the column for this location, just I am assuming here as 1 meter here. Again I am taking here as 4 meter for this location, and this I am taking 3.5 meter for this. Again I am taking 2.5 meter for this location. So now we can say 2.5 plus 3.5 which is approximately equal to 6 meter. 6 plus 4 which is equals to 10. 10 plus 1 which is equals to 11 meter I am considering here. In the vertical direction also we have to assume this vertical distance, just I am taking 1.5 meter. This is 4 meter I am assuming here, and this value is 3.5 meter I am taking here. So 3.5 plus 1.5 which is approximately equal to 5. 5 plus 4 9 meter. The number of the base along horizontal direction will be consisting of 1, 2, 3, 4 numbers in horizontal direction. Vertical direction is consisting of 3 numbers here. Okay. So here this is the center to center distance between the column which is considered for this particular project. Okay. So this is the 2 BHK house plan which is placed in north facing direction. So I was taking this typical floor plan for the project. Okay. So now we can see these are the assumptions which is made for this particular project, which is consisting of M25 grade concrete provision standard system and FE 550 grade steel. And beam size I was taken as 0.4 cross 0.3 and column size is 0.5 cross 0.3. In the same process I was taken slab thickness is 150 mm and dead load condition system is 2 kN per meter square and live load is 3.5 kN per meter square, and loads are considered as dead load, live load, earthquake load as well as the wind loading condition system for this project. Okay. So initially I will open my SAP 2023 software. Now we can see here SAP software will be open here like this. Firstly go to file option, click on new project option. Now we will select the units kilonewton meter. So select the 3D frame option. So we will assume the number of the stories. So in the real time projects for the particular section of the G+3 building, so we will consider the stories are plinth level, ground story level, first story level, second story level, third story level. So it will be consisting of your 4 slab sections, ground story slab as well as the 3 slab sections, and it will be consisting of 1 plinth level also. So we will consider the plinth level also for this building model. So number of stories I am assuming here as 5 numbers, and each story height is 3 meter. So number of bays along length direction are 4, and width direction are just I am taking here as 3, and number of bays are 3 here, and each will be consisting of 3 meter I am considering. Now we will select the custom grid spacing in order to enter the center to center distance between the column for this model. Click on edit data option here, select the spacing option here. Firstly, we will assume the data which is related to 1 meter, 4 meter, 3.5, 2.5 in horizontal direction. So we will click on the spacing. So 1 meter, 4 meter, so 3.5 here, 3.5 here, and last one will be of 2.5 meter. This is the horizontal data which is related to this grid data. Okay. So again in the same process we will enter the vertical data 1.5, 4, 3.5 value. So 1.5, 4, 3.5 value here. So select this option. Again we will click on OK option for this. Now we have to define the beam section data as well as the column section data related to beam dimensions, column dimensions according to given specifications like 0.4 cross 0.3 for the beam, 0.5 cross 0.3 for the column. Go to define option. So go to click on this place mark option for that. Click on add a new property initially. We will select the concrete property related to rectangle section. So here I am selecting beam with dimensions of 0.4 cross 0.3 option here. So you can see here this is the beam dimensions I am considering. So select the grade of the concrete according to our specified grade which is of M25 we have to define, and FE550 grade steel we have to define here. So it is consisting of M30 grade here only. So we will click on the place mark, click on this option, and Indian concrete related to M25 grade just I am adding. So in the same process we will add the 500 grade steel also, 550 grade steel also. Click on add option. So select the rebar option here, and Indian which is a 550 grade. Click on add option. Now we will select the grade of the concrete is M25. So click on the concrete reinforcement option here. So select this option. So select this longitudinal 550. Again this is also 550. Select the beam. We will change this value to 0.03 at top as well as the bottom section. Click on OK. Click on OK option. Now we will select the column. We have to add the column. So according to the definition, it is consisting of 0.5 cross 0.3 is the column dimensions. Select this option. This time I'm selecting here. Again we will add as 0.5 cross 0.3 is the dimensions. Select the property as M25. Click on OK option. Now we will select here as 550 grade, 550 grade. Select the column. Just I'm selecting here as 30. And select the bars which is consisting of 16 mm diameter bar and 10 mm diameter bar based on your assumption. Okay, so here we will assume the number of the bars in 3 direction is 2, and we will assume this as 4 number of the bar. Just I am assuming here. Click on OK. Now after this we will click on OK option. Click on OK option here, and we will select the beam property beam, and we will select the column as C. Click on OK option, so that it will do the modeling of the building structural model with the beams and column sections here like this. Now after this we have to click on this XY view which is related to the plan view. This is the 3D view. Now we will come to the top story. So we will delete all the beam sections which is not required for our typical floor plan. As per the typical floor plan, it is consisting of sections like here like this, but we doesn't require the beam sections at this level, and at this level also we doesn't require, and at this level also we doesn't require. It is consisting of the only the frame sections of the cantilever beams only. Okay, so we will select here. Click on delete option here. Again in the same process I am coming to the top story, next story, which is related to this. Just I am deleting this property. So for the real time projects we will consider only for the projects which is having cantilever beams only. Okay, so here we are considering the cantilever beam sections. Again I am coming to the top story. Again I am selecting this property. Again I am selecting this property. Again I am selecting this property. Click on delete option. Now again in the same process I am coming to the next story which is related to the building structural model. Again we will select this vertical member which is of beam sections. Again horizontal members which is related to the beam sections at this location. Just I am selecting here. Again I'm selecting here. Again vertical section, just I'm selecting delete option. Now in the same process we will come to the one more story, last story. Select. Again we will select here. Again we will select here. Click on delete option. Now after this we have to delete the columns which is exist at this position, Go to view option for that. Select 2D view option. Select XZ plane option. Click on apply. So now we can see it will apply the XZ plane at this location, but we will select the node point. Click on apply option so that it will display here like this. The column section which are presented at this location as well as this location are not exist for the structure. Okay. So as per the typical floor plan, we will select here and we will delete here. Again we will come to the one more section here and we will click on apply option. Now we will delete the column section which is exist at this portion as well as this portion. Click on delete option. Now I am selecting this next section. Click on apply option here. So again we will select these columns. Again I am selecting these columns. Click on delete option so that it will delete the property. In the same process I am going to the next section. So click on this option. So select this option. Again we will select this option. Click on delete option so that it will delete the property. In the same process we will delete the columns if it is exist in this direction, but here we are already deleted the column at this position. No need to delete the columns at this level. Okay, we will see this model in 3D rendering view once again. So you can see here this is the column positions which is consisting of this particular building model which is having only the 9 number of the columns. Now after this we have to add the slab section. Go to XY plane view. So we will select the plane which is related to Z equals to 0 degrees. So this is the Z equals to 0. Z equals to 3 meter. This is the plinth level actually. So this is the level which is comes under the first story section. So go to define option initially. We will define the section property related to area section. Just I am adding the property which is of the slab section, S section, having the thickness is 0.15 I am assuming. We will see that specifications 150 I am assuming here for this model. Go to select here 0.15. This is also 0.15 option here. Select M30 grade. Click on OK. Click on OK. Now we will add this. Go to select this draw 3D view option. So we will select the slab. Click on the draw option here like this for the slabs. So after that we have to delete the slab section at this location. Click on delete option. So that it will delete the slab section at this location. Why? Because it is consisting of the staircases purpose. Okay. So again we will copy these properties to the remaining stories. Before that we have to see all the slab section with the realistic model. Click on the right mark option for that. So click on the object fill. Apply to all windows. Click on apply. Click on OK option. So now after this we have to copy this property to the Y direction condition. Go to select option. Select properties. Area section. Select option. Okay, so after that we have to copy this 1, 2, 3 numbers here. Go to edit option. So select the replicate option. We will select the DZ direction which is of 3 and each will be consisting of 3 meter. So click on apply option so that it will apply your properties in this direction here like this. So click on the cancel option. Now after this we have to define the load cases like gravity loading condition system as well as the lateral loading condition system. Basically, if you consider this building, which is of G+2 building structural model, for the real-time projects, we no need to consider the wind loading condition according to IS 875 part 3 code. Why? Because it is having height is approximately equal to 9 meter. So which is comes under the less than 10 meter height for the building model as per the specified code 875 part 3 code. So 875 part 3 code is specifying that if the height of the structure is exceeding 10 meter, we need to consider the wind loading analysis, but here it is not exceeding. That's why we are not able to consider that wind loading analysis structure. So that's why I am considering only the seismic load, dead load, live load for this building. Okay. So go to click on the define option. Just I am selecting here. Click on load patterns option. So initially it was defined with the dead load condition. We will select the live load condition here. Just I am selecting live load here. And we will select the type according to live here. Click on add. Now in the same process we will add earthquake load in X direction condition system which is related to quick option and we will select as per IS code provision standard system 1893. In the same process we will add the earthquake load in Y direction condition. Click on add option. We will modify the properties inside this earthquake load in X direction as well as the earthquake load in Y direction. Go to modify lateral load. We will select X direction. So which is of zone 2 just I am considering. So soil type is 2 and impedance factor is 1 and I am selecting here as calculated, program calculated. Again I will select the 0.10 with the Y direction consideration. Click on OK. Now we will apply the load cases for this building. Go to select all the building in order to apply the self-weight condition system for the structure. Go to click on assign option, joint loads, forces, select force as 111 value as the self-weight condition system for this model. Click on add to existing loading condition, click on apply option so that it will apply the self-weight condition system for this building model. Click on OK. Now after this we have to apply the wall loading condition system for the frame sections for the beams. So basically we have to calculate the wall loading condition system by considering external wall, internal wall, parapet wall loading condition. So here I am considering the calculator. So you can see here. So external wall will be consisting of 0.23 thickness. We have to multiply this value with each floor height and we have to multiply this value with unit weight of the brickwork, which is comes under 13.8. In the same process I am considering internal wall, which is having 0.125 is the thickness of the wall and 3 meter is the height. If I multiply this value with 20, then it will get as 7.5. In the same process, I am considering one more section which is of 0.125. I have to multiply this respected value with 1.2 meter height of the wall and we have to multiply this value with 20. Then it will be comes under 3 kilonewton per meter. So we have to sum this all the values which is of 13.8 and 7.53 which is comes under 24.3 kilonewton per meter. But some people will consider the 18.8 kilonewton per meter cube unit weight for the brickwork. If you calculate that particular brickwork with unit weight of 18.8, it will be get some dead loading condition with a differ value. So here I am considering maximum amount of the unit weight of the brickwork which I am considering as 20 kilonewton per meter cube for the material. Okay, so that's why it is comes under 13.8 plus 7.5 plus 3 which is comes under 24.3 kilonewton per meter. So go to select option initially, select property, frame section, select the beams here, go to assign option, frame line load, select as distributed load, add to existing condition system. So here we have to select as 24.3 kilonewton per meter intensity. Click on apply option. Now after applying this 24.3 which is related to wall loading condition system, we have to apply the slab load condition which is of floor load condition system for the slabs. Go to select option for that, properties related to area section, select here, go to close option, go to assign option, area load which is related to uniform shell. So I am selecting here as value as 2 value which is considered from this particular location dead load condition. So 2 value here. So I am considering dead load. Click on add to existing loading condition, click on apply option. So that it will add the dead load condition system which is related to 2 value here. Again in the same process we have to add the load which is related to the live load condition system for this slab section only. That's why I am selecting all the slab. Go to assign option, area load which is of uniform load. So we have to consider the value is 3.5 kilonewton per meter square. 3.5. This live load value was considered according to 875 part 2 code. The complete table is available in the IS 875 part 2 code. For different types of the categories, it is having different types of the loading cases. So it is approximately 2 kilonewton per meter square to 5 kilonewton per meter square value will be exist for the building structural model. So now we have to change this dead load to live load condition system. We will select here as 3.5. We will select this particular location. Select the live load 3.5 kilonewton per meter square. Click on apply option so that it will apply the live load condition system also. Now after this we have to add the load combination. Go to define option for that. Select load combinations. Select default design combination according to concrete frame. Click on apply. Click on OK. Now after this we have to apply the support condition system at the base for this building. So for that go to select your ground. Select all node points at the base which is exist only 9 base. Go to assign joint. Select as restraints, fixed supports. Click on apply option so that it will apply the fixed supports at the base for this building. Now after this we have to analyze this structure. Go to analyze option, set analysis option. If you know the complete values related to the DOF's degree of freedoms, you can consider here Why? Because of the considerations of the fixed supports at the base condition system, I am considering all the tick marks here. Click on OK. Again, we will go to the analyze option. So click on create analysis model, so that it will create the analysis model for this building model. Now after this, we will do the analysis. Go to analyze, click on run analysis option. So it will ask you to select the load cases. Click on run now option. So now we will save this model. Just I am saving as G+3 project 1. Click on save option, so that it will do the analysis process under the considerations of the load cases related to gravity loads as well as the lateral load, related to dead load, live load and seismic loading condition system. Now we can see here it was done with complete analysis process for this building model under the considerations of the load cases. It is showing the deflection diagram for the building model under this load. Okay, so I will show you this deflection diagram in the animation view. So click on the start animation option. Okay, so if I click on the start animation option, then it will deflect here building structural model as per the considerations of the load case of dead load. Here you can see it is deflecting here like this. Because of the presence of the high amount of the center to center distance between the column, it is deflecting. So we will see the results related to shear force bending moment for this model. Go to click on the display option here. Select forces option. So here you can pick the support reaction by using joints option. If I click this particular model, you can apply the load cases, then it will show you the complete reactions which is presented at the joint section. Again, we will display the shear force bending moment. Click on this option, go to display forces, frame spandrella cable, select load case according to consideration. Shear to 2 you can apply here, so that it will display the shear force diagram. In the same process, we will select the moment 3 option, select the option so that it will display the bending moment diagram. Click on torsion option, click on apply, so that it will display the torsion diagram for this building model under the consideration. So click on OK option. So this is the complete process of analysis of G+3 building structural model under the considerations of the real-time projects. Now we will design this building. Go to design option, which is available on the top. So it is consisting of steel frame design, concrete, aluminium, cold frame steel members. So we will select the concrete frame design for this project. So initially we will select the code book. For that we have to select the view revised preferences here. So it is consisting of items like design code and multi-response case design and number of interaction or number of interaction points. Consider minimum eccentricity, B by C capacity ratio. If you have, you can enter here. Firstly, we will select the IS code. From this particular ACI code we have to change to IS code, which is available here 456-2000. Again, it will be consisting of your values here like this. If you know the complete values like number of interaction or number of interaction points and gamma value for the steel, gamma value for the concrete, and pattern of live load factor and load factor which is considered for the limit, you can consider here. Otherwise, directly click on OK option and directly select the design option, concrete frame design. Now next step is to select the load combinations. So click on the load combinations option. So here you can see these are the load combinations which are selected for this project. Click on OK option. Now after this we have to click on design option, concrete frame. Click on start designing check option, so that the complete members which is related to beams and columns are started with the designing checks for the structure here like this. After this it will show you the diagram here like this, which is related to longitudinal reinforcement area section. So if you select any one of the member, then it will display the longitudinal reinforcement area section which is required for this particular project. Okay, so you can see here this is the longitudinal reinforcement value which is required for this member for the frame sections related to beams and columns for the project. If you want to display this particular value as per the percentage of the steel value, you can display by using display option and select design option, not display option. So click on design information, select this as rebar percentage, click on OK option, so that it will display the complete rebar percentage which is required for that particular member. So you can see here it is consisting of 0.36 for this and 0.8 for this and 0.2, 0.14, and it is consisting of some other combination. If you want to see the results which is related to beams and columns, we will select this any one of the beam section here. From this, right click on this option, so that it will be consisting of complete data related to the summary, flexure details, shear details for this model. So here I am selecting this summary value, so that it will display the complete summary which is obtained for this particular building model. In the same process, if you click on the flexure details option, it will show you the complete flexure details for this model. In the same process, you can select the shear details option. So it will be consisting of the shear details for this building structural model. In the same process, we will select the column section, any one of the column from this model. Click on the right click on this option. It is consisting of the summary of the reinforcement which is required and flexure details which is required for this project. Again, in the same process, it will be consisting of shear details. You can check this. So if your shear details is within the limits, then you can consider the direct reinforcement value according to our assumptions. Okay. So here you can see these are the assumed values we are defined here for this project. In the same process, it is consisting of interaction curves here and joint shear values here. Again, B by C details here. Okay. So this is the complete process of designing of G+3 building structural model project 1 by using SAP 2000 software. So see you in the next video related to complete designing of G+8 building structural model by using SAP 2000 software. Thank you.